Alright, so on Thursday, the first thing we're going to do is take yesterday's information. So I would go to your note card and go to yesterday's page right here. And let me go full screen. And we're going to focus on that middle part. But one of the things in this chapter isn't really the how to do it. Like you guys did great yesterday. You did great when we did Pythagorean theorem. Great on 45. It's going to be knowing when to launch into which process. So if it were me, I would box this in after you write it down. Whoops. All right. Yep. So, sorry, I almost fell if you're listening to my recording. I didn't fall, almost fall. I bumped my foot. I would take a little bit of time. I'm going to pause the video so it doesn't just sit there dead. But I would write these down, but more importantly will be what you write above it. You're going to launch into this trig process when looking for a side, and again, I would put the box around it till you're done writing, but I would write looking for a slide, but I'd also write what you know, okay? Yesterday, if you know two sides, we said Pythagorean theorem. If you knew you had a 45-degree angle, we were like, oh, that's that special stuff with the root 2. If you had a 30-degree angle, that's that special stuff where we had the root 3s going on. If that's not going on, like on this picture over here, where you're missing a side, but you don't have two of them to use the Pythagorean theorem, this isn't special, that's when we use this process. So when you're looking for a side and you know an angle, and one side. And then I'd write this down, so I'm going to pause the video right here. Go to the next page in your notes, and what I want you to do with that, I'm looking for my page turner. I'll do it up here. There's 2 at the top, and I want you to use your notes that you just wrote down and see if they're sufficient for getting the right answer. So at the top, where it says 8.3b, I want you to follow that process like your little computer program. You're going to arc the angle or highlight it or do something. You're going to head across from the right angle, label it H. You're going to head across from the angle given, label it O. The one left over is the A. One of them is going to get killed off because it doesn't have a date. All right? You're going to choose your trig function, set up, solve. So I'm going to give you about 5 minutes to do both of those. I'm going to pause the video again. So if you're doing these notes at home, you should stop. Our process is we identify this angle as the one given. We always go across from the right angle, then across from that angle. So we don't group up the O and the A. Always just go across right, across one given. The loner is A. One of them will not have a partner. Okay, and it's O on this one. I get it out by crossing it off and get it out of your eyesight. Then we're doing from yesterday, we have our sine and our cosine and our tangent commands. So Katoa, we take these 2 that are left over here and we decide, well, which one deals with adjacent and hypotenuse. Not sine, not tangent, but this is a cosine problem. How many of you chose cosine? Sweet. So we're going to set that up from yesterday. We said the cosine of our angle, which our calculator knows, it's a number though, is equal to the adjacent side. It's important that you do not ha. It's important that you do toa, not teo. Okay, so make sure you grab them in the correct order. So in this case, the x is on top and the 17 is on the bottom. You're actually all the way to step 6 of those steps. The last step said multiply by what's on the denominator, regardless of whether it's the variable or the number. So when we multiply the right by 17, it kills it off, and I'd have x equals 17 times cosine 18. I'm done, because it says equals x. I'm done. The rest is on my calculator. I think if I saw correctly, you guys had a 16.17. We have a backer on that. So they're 16.17. How'd we do on that one? Thumbs up? All right, on the next one, I'm going to go through that same process, and I'm like a little computer program. I'm looking at this, and I'm going, can I use Pythagorean theorem? No. Why not, though? Because I don't like you to have tunnel vision. You should actually, Pythagorean theorem's the easiest, and it's really nice. Why can't I use it on this one to find x? I only have one side. Can I use 45, 45? No, I'm close because I have 41 degrees, but no, not 30, 60, 90. I am forced into trig. It's the only way in the world to do this problem. So I go to my angle given and I somehow force myself to look at it. Then I head opposite the right angle, opposite the angle given. The loner gets the A. One of them won't have a partner. In this case, it's the H. So I'm going to get it out of my vision. I'm staring at a problem that involves the O and the A. So we should have chose tangent. How many chose tangent on this one? Everybody? Oh, snap. Holy crap, Miss L. All right. So tangent 41 equals, and I got to be careful, it's SOHCAHTOA. It's what you do before you get into the pool.
Keep your toes in.
Not soak my tail, right? Don't soak a tail, I soak a toa. All right, so this one's going to be 4 over x. It's a little different. It's going to have one more step, but I still follow the procedure. I multiply by what's on the denominator. In this case, it's an x. I'm recording this. In this case, it's an x, so I'm going to cross it off. This one, I'm not done. I can't go to my calculator. This one, it said equals x. This one does not. Correct? So I need to divide by what? This is a number. Yeah. You don't need to write it down, though, because it's in your calculator. All right? How your calculator knows what it is actually what I'm doing in Calculus BC today. Like, what is behind the scenes in your calculator that when you press, BC is Calculus 2. When you press tangent of 41, how in the world does it know what that is? Or 41.2 or 41.3. And it's actually really cool. It's just a few levels away from where we are right now. So when I divide by tangent 41, now this one I don't remember from last hour. Can I get a help? 4.6.
60.
All right, perfect, thanks. There. So that was yesterday's. Today what we're going to do is figure out, well, what about if an angle's missing? So I want you to go over on the side over here, and I want you to draw a right triangle that looks really similar to mine. I want you to put a 3 over here and a 4 over here. And I'm going to ask you, well, how would I get angle A? So go ahead and label that. We're going to go nice and slow, but not too many today. It's pretty easy. On this one, I'm not, actually, let's even just go put an X in that angle. I am not looking for a side. I'm looking for an angle. If you look above your sine, cosine, tangent buttons, you're going to see this notation up above. So everybody go look at their calculator and kind of locate up above here. The reason they are one over the other is they actually kind of undo each other. They're inverse operations. When you hit sine of 47 degrees, it tells you what the sine is. If you do sine inverse, it'll tell you what the angle was. Okay? So it follows the same process, though. You're still going to say, hey, you're the hypotenuse. Go do that. You're still going to go, oh, you're opposite the angle given. The loner is still right here. One of them isn't going to be in your problem. In this case, the hypotenuse does not have a partner. This is a tangent question. So underneath it, I'd say the tangent of the angle I don't know. So I can't go to my calculator and go tangent 17 degrees because I don't know it. Does that make sense? But I know that it has to equal opposite over adjacent. Your calculator can tell you what angle has that tangent. You just have to know what to hit. Okay? What you do is you say, well, then x would have to equal, and you're going to do what's called the inverse of tangent. It's a way of commanding your calculator basically to work backwards, to search its database for the angle that has a tangent of 0.75 or 3/4. So you're going to go to your calculator and you're going to hit, go ahead and draw an arrow, you're going to hit what button before you hit tangent to get above it? Second. Yep, so you're going to go second tan, and then you're going to do 3 divided by 4, or you could do 0.75. Your calculator could care less whether it's a decimal, a fraction, an unsimplified fraction. It does not care. But what does it say that angle is? 36.8.
8/7.
Now, I want you to show you, this isn't magic. Remember, trig is used for when you can't physically measure things. Maybe that was the angle I need to head up with my airplane, right? For some reason, like they say, the traffic control for airplanes says, you know what, head up at a 36.87 degree angle and you'll be fine and you won't crash into any of the other planes that are heading out, correct? But watch how that works. This is actually, everybody kind of put your pencils down and take a look, because I have that exact same situation sitting up here with measurable tools. Trig is used when you can't measure anything. So I made it. Can you see where that says 4 inches? I physically made a side that was 4 inches. And I'm not going to turn my ruler. Well, maybe I will if I can remember how. There's a little command on here for turning. There it is. So if I turn my ruler this way, whoops, there it is. I actually made this one to be, do you see how I made it exactly 3 inches? I constructed a 4 by 3. I have a question for you. Without measuring, could you tell me what this missing hypotenuse is? If I had a 4 down here and a 3 over here, what would you use? Go do it. Tell me what that missing side's going to measure. Again, we use all this stuff so we don't have to measure, or in situations where we can't physically measure, which it happens a lot in the real world. Like mountains are really high. I don't know how tall it is. Like I can't measure it, but this I can. It's a small little thing on my smartboard. But what does it say? 5. Let's go see if I can get that to turn really well. Whoa, 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 whoa. It says it was 5, correct? So let's go pull that up here, and let's go stretch that sucker out and get that off of there. All right, it's actually kind of important that you know what you're doing, not just how to do it. Perfect. 5 inches, correct? You guys just told me that that angle was how many degrees? 36 point. Let's go see if our trigonometry holds. Oh my gosh, look at that. Everybody look. Yeah, look at that. 35, 36, just a titch past it. So what you are doing with your trigonometry is finding measurements without measuring. Does that make sense? Are you good? All right, so now you know how to find angles. Let's go practice. Okay, so back to our sheet right here. The first thing we're going to do is just practice on our calculator for a little bit, just to make sure you get kind of some muscle memory with what buttons you need to click. I've got a lot going on up here, so my computer's a little slow, but let's all go do letter A up there. You know that the opposite divided by the hypotenuse gave you this. Yesterday we did an angle and we wrote 0.4226 down. What angle did we press? Well, you're going to go to get that angle back. I have to tell my calculator to go backwards. This is actually really poor notation, so I'm not going to. That -1 bugs me, and we don't use it in calculus because it means 1 over something, and that's not what this is. But don't worry about it. All right, so go ahead and do that on your calculator and tell me what angle must have had that sign. I don't know what it is, so I actually do need help from you, Avery. 24.99, so about a 25 degreer is what I'd have to set my thing to if I wanted opposite over hypotenuse to be that. Let's go try a cosine with B and a tangent. I don't think we need to do all 8 of them, or 6 of them. Go ahead and do letter B, and go ahead and do letter F. And again, you use this when you're looking for the angle back. And so on your calculator, you should have hit cosine inverse 0.8192. And on this one, tangent inverse 11.4301. I have no clue what they are. So let's just go ahead. Tell me really quick, Avery, so we can move on. Because this is easy.
34.9.
Do we have a background at 34.99? Excellent. Thank you. And over here, I just don't want to bring my calculator up because I'm running on recording. And I've got YouTube in the background. And I've got everything going. It's going to go really slow. What was this one? 85? And Ronan? Yay. All right, so what I want you to do right now is beneath here, I want you to see the application of this. A contractor has been hired to build a wheelchair ramp, okay? That ramp needs to meet at 5 feet above the ground. That's where the door is or the porch or whatever. He's got a parking lot over here, and he measures this way. That's very measurable, correct? So measure. And let's suppose this was 22 feet. And suppose they want to know if it's going to pass building inspection. This is very applicable. The law for wheelchair ramps is they cannot exceed what's called a grade of 8 degrees. It's illegal. They have to be that or less. Does that make sense? So we want to know what this angle is, because if we just go and build it, and then they come in every building when you build something new, Miss L knows this, you have to have a building inspector come, correct? You build a deck, a porch, a wheelchair ramp, a garage. The city sends out a building inspector, and they go check it out. And if that building inspector says, this angle's over 8 degrees, you got to tear that ramp down. You better not build it before you know if it's meeting building code. Does that make sense? So what you're going to do is you're going to say, well, I can't measure. I'm not going to go out there with my protractor. That's stupid, right? What I'm going to do, it's not stupid, it's just stupid. All right, so what you're going to do is our whole process. You're going to go, the wheelchair ramp's the hypotenuse, this guy's the opposite, this guy's the adjacent. I'm not dealing with that right now. I'm just dealing with what I measured. Before I build the ramp, I need to know. So what trig function would I do very quickly? Or would actually you wouldn't do it, your contractor would. If they're like, can we fit this ramp in here? They're going to legally meet building code. What trig function are they going to use? Sine, cosine, or tangent? Tangent. Yep, so they're going to say the tangent of my angle, if I build it like this, 5 feet off the ground and 22 feet away from the parking lot, right? And then they go to a calculator, a computer, or whatever, probably a computer, an iPad, and what they would do is quickly go, tan inverse, please tell me what that angle is before I build it. Because if it's over 8 degrees, and I build it anyway, it's going to break building code. What is it? I just made those numbers up. What is it? 12 what is it? 12 point what? Can't get that. What am I going to have to do then?
You're going to have to make a
I have 2 options. Tweak this so it's lower, but then I better build a little something so I can get to the door. Or if possible, build it farther out, correct? But I better not build it like that or they're going to come and say, look, you got to tear that sucker down. So very applicable math. We're going to go to the next page and we're just going to practice a little bit. On this one, we're going to find angle X. On this one, we're going to find angle X. And on this one, we're going to find angle B. I'm going to start the first one, and you're going to do the second 2, and then we're going to be done with notes. So I look at this, and I go, well, what are they asking me to find? An angle. I'm not going to do Pythagorean theorem on that. I'm not looking for a side length. So again, don't think of tunnel vision. What's my process? Across from the right angle, across from the angle I'm looking for, and the loner. Oh, you don't have a partner. What trig function? You guys are already doing it, but what trig function am I going to use? Sine, cosine, or tangent for this guy. This is a sine one, and again, if you're like, I don't know, I would always write this on the top of every paper for a while, just so I'm just looking at it. But we've got O and H. So I'm going to say the sine of my unknown angle is equal to the opposite side over the hypotenuse. And you're like, oh, I'm looking for the angle. So what button are you going to hit on your calculator? Sine inverse. Do you need to reduce the fraction? Your calculator doesn't care. You could do 3/5, you could do 0.6. Your calculator couldn't care less, so I wouldn't bother reducing it just in case you did it wrong. Somebody tell me what we get, and let's go nearest 10th.
36.9.
36.9. Perfect. Now I want you guys to do the other 2. You're going to find angle X. Again, make sure you arc that. You're going to find angle B. Make sure you arc it. Make sure you HOA in that order. Cross off the lunar and have at it. Put your pencils down when you're done. Or stuff. Having fun using all these extra colors lately. I don't know why. It makes my heart happy. You done already? Pencil it down when you're done or you're stuck. And then we'll do our last task of the day. Alright, most pencils are down, guys, so I'm going to have at it just to give you homework time. I will talk you through, see if you did it. We always focus on the angle given, or that we're finding. We always head across from the right angle first, across from that angle second. The other one gets the A. Correct? That process, you can never goof up the sides if you do it that way. Could you possibly miss out, goof them up if you do it that way? If you do it your own way, you're going to goof these two up sometimes. So go across from the right, across from the angle, the loner's always the A. Then you're going to cross off the one that doesn't have a partner. Choose your trig function. What'd you guys choose? Sine, cosine, or tangent? Cosine. Awesome. The cosine of my unknown angle. I'm not going to go hit my cosine key. That means I need to know the angle. But I know that whatever the cosine was, I can get it by doing 15 divided by 20. You could change that to a decimal, but your calculator doesn't care. So to get that angle back, you have to undo it or do cosine inverse of 15 over 20. And I have no idea. 41.4? Awesome. Thank you. And the last one, check your own, is going to be, again, the same process. They said to look at angle B. I'm going to highlight it, put a dot, put an arc. I'm going to go hypotenuse. Across, opposite, across. A gets the leftovers. Who doesn't have a partner? This problem won't involve hypotenuse. It involves O and A. How many of you picked tangent? All right. We're going to go the tangent of my unknown angle equals opposite. It's not SOHCAHTEO, it's SOHCAHTOA. So don't go 9/12. This one would be 12 over 9. Now you need your calculator to search its database for the angle that has a tangent of 12 ninths. So you're going to go tan inverse 12 ninths. Can you tell me what you got? Somebody who did it right? 53.1? Okay, I'm not going to write it down then. All right, I'm going to wait on this because I didn't see it on the test, and I'm not sure if the other teachers are doing it, and we're a little ahead. So I'm going to hold off. If we need to do that, we'll tack it on later, okay? I just don't want to mess with a good system right now. So your assignment is going to be to take a blank sheet of white paper. You're going to hamburger hot dog it again so that it's got 8 sections. You're going to open your Chromebooks to Delta Math, and I'm going to show you the work you need to see, or I'm going to hand it back to you. It's not about the answer, it's more about the process. And honestly, first hour, the ones who were doing it this way were slower because they were getting the red X's instead of the green checks. There's not very many problems. But I'm going to be very, very picky in what I need to see on your paper. All right? Go to Delta Math. Go to 8.3b. Yeah, I want them to see this too, so. One more? Yeah, just a sec. So you're going to fold it. Can you pass that back? Hamburger hot dog it. Which one first? I don't know. Yeah, hot dog hamburgers.
You'll send me one more paper.
One more? I'll do it even for you, Mike. Hot dog hamburger. There you go. You'll have 8 boxes, 4 on each side. On one side, I want you to write finding angle, and I want you to write SOHCAHTOA. Then you're going to flip it over, and on the other side, you're going to write finding side. SOHCAHTOA. Okay, we're going to do 4 of today's and 4 of yesterday's. And I'm going to tell you exactly the work I need to see. When you're ready to roll, hop into Delta Math. It's going to say 8.3b. The first one says finding angles. So I'm going to tell you what work I need to see. We're all going to do the first one together. And if you don't get a green check, because we're all at different ones, you're going to raise your hand. Okay? I'm going to wait, give you a little bit of time to get into delta math. Your first one is going to have a missing angle somewhere. You're going to draw the picture regardless of what your triangle looks like. I'm going to pretend that I opened delta math and this was my first one. And mine had an X right here. And mine had a 10 right here. And mine had a 12 right here. You need to draw the triangle. What do you need to do? Or I'm going to hand it right back to you. Okay? And not assigning many. I'm just going to be really picky. Regardless of how you drew your triangle, you're going to head across from the right angle. Then you're going to head across from the angle with the X. And then the last thing you label is the A. We're all going to have that on different triangles. We're all going to cross off the one that does not have a partner. Mine's the opposite side. But I made mine up. Yours might be adjacent or hypotenuse. We all are going to look at the top of our finding angle and we're going to say, which one is it? Mine's cosine. I need to see you write two things. The cosine of my angle, yours might be tangent, is adjacent over hypotenuse. And then I need you to see x equals cosine inverse of 10/12. And then I want to see an answer, and I don't know what mine is. Let's round, what does it say to round to? It should tell you. Tenths. Okay. Miss L, can you cosine inverse 10/12 for me? Well, they're doing theirs. Theirs is different, so. Don't need to reduce the fraction? You could. So I'm going to call mine 33.6. This is what's going to be in the box. Okay? I would get a green check mark for that. When you flip it over and do the sides, you're going to do like we did yesterday. You're going to write sine 37 degrees equals x over 5. Multiply by 5, go to my calculator. You do not necessarily need to draw the triangle on the back. Did you get a green? I'm picky, but I'm nice. I'm not giving you a worksheet with 20 of them, but you better look perfect. Perfect. Yes. Raise your hand if you're not getting a green check. We'll get you fixed up. Yeah. And you should have chose sine. So you should have done second sine. And did you do this? I bet. Yeah, that should be fine. 6.5. I bet you did it upside down. I bet because, yeah, my guess is you had your fraction upside down. Brody was gone yesterday. Thanks, Miss L.
Getting to understand it.
Hmm?
I'm getting to understand
You are getting it.
So we want to see the arrows?
I like them. But I guess I really just want the H, the O, and the A on there. I like the arrow so I know I go across and across then. Yep. Let's see. Your X was up here, so this is your opposite. This is correct. Perfect. Which trait goes with is tangent. You have a. You wrote 39 and then put a 36. Everything's perfect. Your six flipped over. That's the best mistake to have, Ellie, because it means you know what you're doing. But for some reason, your 6 turned into a 9. I love delta math because you know if you get it right or wrong, but do not do it in your head. Let's see, we should have picked cosine. Cosine x would be 35 over 77, and you wrote 34. You did the same thing she did.
You guys,